So let's talk about rates of travel. Uh, Sometimes people call that speed, sometimes people call it velocity. Um, and we're going to start off with simplistic examples today. As the course progresses, um, things get a little more nitty gritty. But we're going to introduce a concept called velocity, namely average velocity. And we're going to go back to the displacement examples that I used before, where you have your house, you got school, you have your friend's house, same number line, same frame of reference. Your house is the origin, school is positive 2 kilometers away or to the east, and your friend's house is negative 1 kilometers away or to the west. Now, when you walk to school, it takes time. And if you walk slowly with a long amount of time, you're going to have what we call a lower average velocity. If you walk really fast or run, or even hop in a car, you're going to get there much more quickly, you're going to take less time, and therefore your average velocity, that rate of speed, is greater. You go more meters per second or more kilometers per hour. And that ratio of displacement over time, again, average velocity. Now, this is measured in units of distance over units of time, which I don't have written. That can vary depending on the problem. You can have meters per second, feet per second, miles per hour, kilometers per hour. Typically in this class, we're going to deal a lot in meters per second. That's going to be the most common unit, although in this beginning part of the course, sometimes kilometers per hour do creep in. It is very rare that we'll bring in British or English units at this point. Okay, so let's go over it. Let's say we go from home to school. Nice leisurely walk. That's where we're going to define that. We're going to say, all right, we're going to start at home. That's our initial position. And we're going to end up at school. I don't know why I wrote that twice, really. Let's say, 2 kilometers, it's a good ways away. Let's say that takes, on a nice leisurely day, and you're walking to school, let's say that takes, so here's my clock, it's time. Let's say it takes about 0.50 hours. Half hour. Say it takes a half an hour to walk. Probably, if you really hustle, you can get there much quicker, but so, from here to here, 2 kilometers, took a half an hour. So if I wanted to know the average velocity, the formula, if I expand it, by the way, if I expand the deltas, delta means change in, distance, change in time, which is your final minus initial, your final minus initial. So my final position is 2, 0.0, again, sig figs. My initial position is 0. My time. Well, typically, when we start a timer, we start talking about a stopwatch. We start at time 0. The clock is zeroed when we begin timing something. And let's say it took us a half an hour, so 0.50. I'm not using 30 minutes here specifically because when I solve this, I do get positive, which is important. And I will notice that it's 4.0 sig figs, 2 sig figs, 2 sig figs, so still 2 sig figs. And the units are kilometers per hour. I always jump from H to HR. I don't know. I don't keep consistent with it, sorry. So positive 4 kilometers per hour. That's my average speed to do that walk. But what's wild is we don't know a lot of details about what's going on during that 30 minutes along that walk, along that pathway. It could be the case that you're just walking at a nice constant pace. And if you're moving at that nice constant pace, not only is it your average velocity, but it's also what we call a constant velocity. Walking at a nice constant pace. It's the same rate every moment. That's different than just a kind of random set of motions in order to get from here to here. So let's say you start from home. Let's say you're walking really slow. You're going to school slow, and then you stop for a while. Maybe you're looking at some flowers, maybe there's an animal, maybe you see a friend and you're just chatting, and you're like, you look at your clock, oh no, I'm getting late for school, and then you run the rest of the way to school. So during that 30 minutes, you have all kinds of weird motion, or sometimes even non-motion. Maybe you're even stopped for a little bit. But the physicist doesn't care about that. The physicist only cares about, well, I started here, I ended there, it took you a half hour. All kinds of things could have happened in between, but we only care about the initial and the final positions, and the final and the initial times. A lot of times in this class, we're going to assume that the motion from A to B is constant in a lot of scenarios. But sometimes it's not. Sometimes we're going to have things speeding up or slowing down during those motions. Regardless, what's even more wild is during that time, maybe the person started from home, maybe the person ran to their friend's house and ran all the way back to school. That would be a lot of traveling, but still only in a half an hour. And if they ran all the way back and all the way back, the average velocity is just still. You started here, you ended there, it took 30 minutes. The physicist isn't going to care about all the randomness of the traveling along the pathways. Average speed may worry about that randomness and the pathways. For instance, let's say, in the first example, that you go from home, you go to school, and you go direct, and you go in a nice constant motion. Well, the average velocity was positive 4 kilometers per hour, again, 4 kilometers to the east. And in that case, your average speed would also be 4 kilometers per hour. Now remember, speed, just like distance in the previous examples, doesn't really matter about direction, doesn't care about direction. But if there was a second example where you went from home to your friend's house and then to school, and again, we're defining the trip as going from home to school. That's the definition of, that's how we're defining this. Well, then things get a little wacky because your average speed is going to be different than your average velocity. Because your average speed is going to go from here to here, that's 1 meter. From here to here, that's another meter. And then to here, 2 more meters. So your average speed in that case would be the average speed in this case would be all of your meters, all of your distance, all those 4 meters, all over, where we're saying you still only did it in a half an hour. So you're probably moving pretty quick to do this. 8 kilometers an hour. So be careful when you're looking at problems. Are they asking for average velocity from start to finish? We don't care what happens along the way. We don't care about the pathway. Or are they asking about average speed? The pathway is very important between start and finish. Another example is if we go from home, let's say we go from home to school and then back again. So we're going to say we're looking at a round trip. Well, again, and let's say this round trip this time took us, let's say we were a little faster today. Let's say that we did it in 0.75 hours. Again, in HR versus H. 3/4 of an hour, 45 minutes. So we were a little faster today, a little more pep in our step. So let's go from here to here and back again. Well, here you'll notice the average velocity, final minus initial positions. Well, I ended up at home, but I started at home, and I took 3/4 of an hour to do it. 0 kilometers per hour. Wow, I'm having a problem today. And that's funny because you did travel. You went to school and back, but the average velocity was nothing because in the end, the way we define the scenario, you didn't go anywhere. Now that's different than average speed. Because in average speed, remember, it's just about the pathway. Well, we did travel 2 meters, then 2 meters more. It's independent of the direction. So we went a total of 4 meters. 2 plus 2. And we took the 0.75 hours to do that. And if we look at that math, we took, well, let's see, 4 times 3/4, which would be 4/3, which would be 16/3. 5.33 repeating. I have to worry about significant figures. 2 sig figs, 2 sig figs. So I have to take this and round it accordingly. So 5.3 kilometers per hour. So average velocity, nothing. Average speed, well, yeah, I was traveling distances with respect to time. So you're going to get other examples of this where objects are going to travel forwards and backwards. You're going to have examples of this where objects travel, stop for a little bit, and keep traveling during the trip. But keep these core definitions in mind. Average velocity, where do I start? Where do I stop? How much time passed? And I don't care about all that happens in between. Average speed, I am going to care what happens in between in terms of the distance of the path traveled in that time. That's going to be important. And then lastly, one of the concepts is, and usually it's assumed, while the motion is happening, if the motion is nice and consistent while traveling, that average velocity is also a constant velocity. That doesn't always happen, but it is prevalent a lot in this course.